In this video, we will talk about Goodmans and Kruskals gamma. Gamma is useful for when you have ordinal level data. For this example, I will use the problem in your textbook that reads above. The following 96 students were ranked from high to low with respect to their consumption of alcoholic beverages, X, and their daily use of marijuana, Y. For these data, compute a gamma coefficient to determine the degree of association between consumption of alcohol and use of marijuana, and indicate whether there is a significant relationship between X and Y. So here's a cross-tabulation of marijuana and alcohol use for randomly selected participants. And we can use a gamma test to see if marijuana use and alcohol are positively associated. In other words, a high score on one variable leads to a high score on another variable, or a high rank on one variable leads to a high rank on another variable. Or we can also see if there's a negative association, meaning a high rank on one variable leads to a low rank on another variable. Here is the formula for gamma, and it has two terms, N sub A and N sub I. N sub A stands for number of agreements, and N sub I stands for number of inversions. The first step in calculating gamma is to arrange a cross-tabulation like I've done right here. And on the cross-tabulation, each variable needs to range from high to low. So across the top, we have alcohol rank from high to low. And across the side, we have, or up and down, a marijuana use from high to low. So imagine that these study participants were all in a room and we were to select two of them at random and compare their usage. Let's say the first participant was from this group. This group is high on alcohol use and high on marijuana use. And we're going to select another person, maybe that falls in this category over here, low in both marijuana and alcohol use. If we compare these two participants in each group, we can say that the participant in our high group is higher on both variables than the participant in the low and low group. That is, the person has a higher marijuana score as well as a higher alcohol score. And this is referred to as an agreement. An agreement is when both variables vary in the same way between the two individuals. So for an individual in this box, alcohol and marijuana use are high. There's a high association there. And a person in this box, alcohol and marijuana use is low, and so that is the association there. And they're both considered to be in agreement because they are varying in the same directions within each other. So both of these scores are lower and both of these scores are higher, and that's the relationship that these two scores share. It's an agreement. So the gamma formula asks you to calculate the number of agreements. And so we're going to do that right now. And I'm going to start, as I do, I'm always going to do with agreements, in the upper left-hand corner to calculate the total number of possible pairs of people that are varying in the same direction. So we have, for example, 5 people in the high group. And we have all of the people in these 4 groups that are lower on both measures than the people in the high group. So as one gets higher, the other gets lower. There we go. So what I'm going to do is I'm going to do a multiplication calculation to multiply the number 5 by all the rest of these numbers here. And that will give us the total number of possible pairs we have between somebody in the high group and everybody else who has a lower score on both. So without further ado, I'm going to do 5 times the sum of these 4. And I end up with 195. Now that's not all of the agreements. That's only the agreements that happen to be with the medium or the high group. And so what I'm going to do is I'm going to move over one cell to the group that's high on marijuana but medium on alcohol. I'm going to look for groups that are lower on both measures. And to do that, I'm going to look down and to the right. That's how we do it, down and to the right. And so the people who are lower on both measures are right here in these 2 cells. So that's my next calculation for an agreement is 7 times these 2 cells that are below and to the right, and I end up with 105. And I just looked at that number. I realized that doesn't look right just based on I've done this calculation before. I'm going to click on it, and I see right here I didn't actually sum up those numbers. I just selected them. So I'm going to go back, and I will make sure that this word sum is hit. And I'm going to select these two boxes. And whoop, now that is definitely not the right number. Well, hold on, folks, just one moment. Okay, starting again. Here we go. 7 times the sum of these two boxes. Okay, I know that that's the right number. All right. So far what we've done is we've multiplied 5 times these 4 boxes here. We've multiplied 7 times these 2 boxes here. And now moving over, are there any scores that are lower on both measures or both ranks than this one right here? No, because we're in the lowest group possible. So we're not going to be able to calculate any agreements using this cell right here. So I'm going to go down to the next cell to see if there are any other groups that are lower on both measures. And if I look below and to the right, I do see that there are 2 cells that are lower on both measures. So for my next agreement, I'm going to start with 10 times the sum of these 2 cells. And so good. I'm going to move over here. Is there any cell or cells that have lower scores on both? There's actually only one. So I'm just going to do a simple multiplication of 8 times 10 here. Okay. Now as I move over to the next row, again, same thing. I'm not going to find any cells that are lower on both measures because I'm in the lowest here. And same with all of these. These are all going to be the lowest, so I'm not going to be able to use those in my agreements. So for this group, I have all the agreements that I'm going to have, and our formula asks us to add them up. So I'm going to do that. Equals the sum. Okay. And so the number of possible agreement pairs we have in this group is 610. So we're doing good. And next we want to sum up our inversions. And inversions happen when a participant is higher on one measure but lower on the other. So for the last set of agreements, we started at the upper left. So this time we're going to start at the upper right, and we're going to start with this group that's the alcohol low group. So are there any groups that are higher on one measure but lower than the other than the alcohol low group? And the answer is yes. Nobody is higher on marijuana than this group, but we have some that are lower on alcohol. Actually, lower on marijuana. I'm saying that wrong. Okay. Here we go. These 4 groups are higher on alcohol, but lower on marijuana. So in this case, it's not an agreement because there's some differences here. In one sense, these groups are higher, and in one sense, these groups are lower. And so we're going to call this an inversion. And in order to calculate this, I'm going to go ahead and put equals, and then 20 times. Oh, I'm doing it again. What am I doing? I'm doing all of these errors on purpose so that you learn. All right. And I'm going to sum up these 4. And hit return. Okay, so we have our first set of inversions. Now, this time we're going to go to the left to the next one. Oh, not yet. So I've got 7. Are there any scores that are higher on one measure and lower on another? To find this, I'm going to go to the left and down. So I have these 2 boxes right here. Come on. So I'm going to do equals 7 times the sum of these 2 cells. Okay, there you go. So I've done 20, I've done 7. Now in this is the same case here. This This is the highest group in alcohol and marijuana, so there's not going to be a group that's higher than that group. So we're going to skip down to the next one that we can work with, 15. And if we go down and to the left, we've got these two cells here that we can match it with for an inversion. So I've got equals 15 times the sum of these two. All right. And as you can probably tell, we've got one more to go, which is this one right here, 8. And the only one that is higher in one measure and lower than in another is 15. So we're just going to do a very simple 8 times 15. All right. And so just with our agreements, we're going to go ahead and add up our inversions. And we have a total of 1,390 for our inversion pairs. So gamma compares the number of times that a pair reflects a positive association to the number of pairs that reflect a negative association. In this case, our gamma is equal to the number of agreements minus the number of inversions over the number of agreements plus the number of inversions. So let's go ahead and calculate that right now. An equal sign. I'm going to do the numerator first, the number of agreements minus the number of inversions over, more parentheses, the number of agreements plus the number of inversions. And this is going to give us our gamma statistic, which is negative 0.39. And since this is a negative number, it indicates that there's a negative association between marijuana and alcohol use. So gamma ranges from -1 to +1, and the sign indicates whether it is a positive or negative association, and the size indicates the strength of the association. So a gamma of 0 would indicate no relationship between marijuana and alcohol use, and a value of 1 would indicate a perfect association. And so we're looking at this, it's negative 0.39. We don't know if it's statistically significant or not, but we can test this significance by using a z-statistic, using the formula on the right. So I'm going to break this down into a couple different steps to make it easy. So the first thing I'm going to do is add the associations plus the inversions. And the next thing I'm going to do is the denominator, which is the number of participants we have, 96, times 1 minus g squared. So that is going to be 96 times, and in parentheses, 1 minus our gamma squared. And we end up with this as our, and I think there is an error. So sorry, folks, that is our denominator. And so now what we're going to do is we're going to multiply gamma times the square root. So we're going to go gamma, actually I'm going to put it over here where the z is, equals gamma times the square root of our numerator over our denominator. Okay, and that gives us a z-score of negative 1.93. Now, as we've done before, we compare z to our critical z value of 1.96. We just get rid of the sign there. And we see that it does not meet the significant level of 1.96 for z. And so we say that in this case, there is not a significant relationship between alcohol use and marijuana use. So to summarize, the calculated gamma of negative 0.39, which suggests a negative association between marijuana and alcohol use when one goes up, the other goes down, for example, is actually not statistically significant. So any differences we're seeing are due to chance. So after calculating gamma, you might be tempted to drink a lot. Don't. Instead, just practice. The more you work out gamma calculations, the more that they will make sense. And this video, as well as the last, dealt with correlation of ordinal variables. The next two videos will deal with correlation of nominal variables. And the next two videos will be much quicker and easier, I promise.